Okay, so this is another problem, and I've written this one out for you. So find the equation of the curve. Find y, right? That's what that means. Find what y is equal to. It goes through this point. This is my initial condition. This will help me to find c, right? Whose slope at the point xy is this. What do we know the slope is? Y prime, right? From first semester, we know the derivative is the slope of the tangent line, and that's what this is. Okay, so y prime is y squared over x cubed, and this is our initial condition. So starting off with y prime, so rewriting it as dy over dx, then y squared over x cubed, then separate the variables, multiply by dx, divide both sides by y squared, right? To get the y's on one side, the x's on the other. Integrate both sides. So add 1 to the exponent, add 1 to the exponent, lots of negatives, right? So I'm even going to take the time to rewrite these two things with the negative exponents, putting them in the denominator. So again, this is the easiest place to solve for c. So I'm going to do it right here and now, even before I do anything with the negative signs. So this says y of 1 is 1. So that means when x is 1, y is 1. So put in 1, and so I get c is equal to positive 1/2. So put it in. So now be really careful here. So first off is, what did I do first? I multiplied both sides by y, right? So I took this thing here and I multiplied this side by y to get a -1, and multiplied this side by y to get this y here, right? Okay, so I'm solving for y. So now let's put all of this in the denominator, right? Oh, yuck, I've got ugly fractions in the denominator. So how about we fix this? And I'm expecting you to be able to do this because you're second semester college math people. So you want to multiply top and bottom of this fraction by 2x squared. So multiply -1 by 2x squared. Multiplying this down here by 2x squared, I get a -1. Multiply this by 2x squared, I get an x squared. So this looks much nicer, right? So this here, so you should be able to recognize that this is the same as this. Yes? Okay. All right. So let's dig into the next one. So here we go. Oh dear, what do we have here? Looks like 3 terms, but let's start off with rewriting the y prime as dy over dx. And then I'm going to move this y term to the other side. Okay, so I want to get the y's by the dy's and x's by the dx's. So I think I'm going to need to factor out the y, right? Factor out the y, because I'm going to want to divide by the y to get it over here to this side, correct? Okay, so let's divide by the y. So I'd have 1 over y dy, and then I'm going to multiply by dx, and I'm going to divide by x to get it over here, right? Okay, there it is. So I've got all the y's by the dy's, all the x's by the dx's, and I'm reminding myself, I'm pausing right now, I have an initial condition, so let's remember to solve for the c. Okay, so let's take the integral. Integral. Okay, this gives me ln of y. Ooh, what to do here? You've seen things like this before. You want to separate around the addition in the numerator, right? So this gives me 2x dx. So this gives me ln of x plus x squared over 2, so the 2's cancel, plus the c. Okay, so now let's use y of 1 is 1 to solve for the c right here and now. So ln of 1 is 0, and this is putting in x equal 1, so ln of 1 is 0, and I'm putting in x is 1, so 1 plus c, so that gives me a -1 is a c. So I'm going to plug that in to this stage right here, right? So ln of y, ln of x, plus x squared minus 1. Now finish off solving for y by taking the e of both sides. So e to the ln of x plus x squared minus 1. Okay, let's fix this. So remember we talked about x to the a plus b is x to the a times x to the b. So see how I have this up in the exponent like this? So this can be rewritten as e to the ln of x times e to the x squared times e to the negative 1, correct? Because I just used the addition or subtraction up in the numerator. So what does this say? This says y equal e and ln cancel, so I get x. And then I have this e to the x squared, and this is times 1 over e, or like over e, right? This is the specific function that solves the differential equation.